An escape room is a game in which a team of players cooperatively discover clues, solve puzzles, and accomplish tasks in order to escape the room. Our virtual escape room allows users to join through a website, and once the game begins, they're presented with a series of tasks. Upon completion of the tasks, they will escape the room.
To actually play a game, a user will first have to turn on their ESP, which will initialize the user and connect them to the Python server. Once the ESP is connected, a user will see a user ID appear on the LCD display, which the user will have to put into the website form to actually enter a game room. To submit the form, the user clicks on the Join Game button, which sends the user to a game room with the ID they inputted in the form. At this point, the user will wait for all of their friends to join the game room by entering their valid user ID from the ESP and the same game room ID that all of their friends are using. However, the game only allows 2 to 4 players, so if a fifth person tries to enter the website, will show them a descriptive error. Once everyone who wants to join a game room has joined it, the user can ready up by pressing the Ready to Play button, which sends a post request to the server telling the Python server that a specific user is ready to play in a specific game room. If everyone in a game room is ready to play, then when the ESP client and the website client request data from the server, the response will be a task for the ESP and a game room data for the website client. The ESP takes this task number and using an FSM runs a piece of code that displays a specific task for the user to complete and records input data from the different sensors that the ESP is connected to. At the same time, the website is displaying the current state of the game room, which includes the task the room is on, the scores of each player, and whether or not a specific player has completed a task, which is marked by a small check mark by the user's name. Once everyone has completed a round, the request that the ESP and website are sending to the server will produce a different response with a new task in the case of the ESP and a new data point in the case of the website client. To see exactly how these requests are handled, go to Detailed Code Layout section of this report. Finally, the game is finished once all the rounds have been completed and a bar graph is displayed showing the scores of each user at the end of the game, keeping in mind that the lower scores are better.
The game begins by presenting the user with a series of instructions explaining the room and giving hints about the answers to upcoming riddles. Once the last page of instructions is read, a long press will send up to the server that the user has completed reading. Once all users have completed the reading, the game begins. The user can also scroll through the reading with short button pushes.
The riddle prompts the user with, "Introduce yourself. Hold down the left button to speak." The user should then hold down the left button while they speak into the mic. Any introduction that starts with, "Hello, my name is," will be the correct response. Once completed, it will say, "Correct," waiting for other players. The riddle prompts the user with 10 small steps for man. The user then must take 10 steps with the ESP. They can do this by either putting it against their hip and stepping or tapping it against the table. Once completed, it will say, "Correct," waiting for other players.
During the multiple choice question, a question is displayed for the user until they press a button. After they press a button, one of the answer options will be displayed. The user must tilt the ESP forward and backward to display different answers. A long press will submit the currently shown answer.
The screen prompts the user to create an earthquake. To complete the riddle, the user must shake their board for at least 2 seconds. When the ESP32 detects an earthquake, the LCD displays "Task completed."
The tallest building question is a trivia riddle, with the answer being Burj Khalifa, which is the tallest building in the world. Users select letters with short presses and scroll by tilting the ESP32. A long press submits the answer to solve the riddle.
The ball game offers users a chance to earn back some points. The minigame lasts for 30 seconds, and each token collected subtracts 20 points from the total score. At the end of the entire game, the user with the lowest score wins.
The riddle prompts the user with, "What has teeth but cannot chew? Hold down the left button to speak." The user should then hold down the left button while they speak into the mic. The correct answer is a comb. Any combination with the word comb will cause it to be marked as correct. The riddle prompts the user with, "What can you hold without ever touching or using your hands?" The user should then hold down the left button while they speak into the mic. The correct answer is your breath. Any combination with the word breath will cause it to be marked correct.
The upside down riddle works by directing the user to a website with written text from the MIT Minded Handbook. The user should notice that the text has a few letters that are incorrectly capitalized, and upon solving the riddle will determine that they should turn the IMU upside down to complete it. Once it's completed, the LCD will display a message showing that you've completed the riddle. The Morse code riddle works by taking an input Morse code signal from the user. If the user inputs the letters HI, then the server will respond with the correct message and the riddle will be solved. The server works by taking in a string of dashes and dots and converting them into the English Morse code message. The gesture riddle works by taking in data from gestures done by the user and comparing them to a stored database of gestures. The correct gesture is a vertical O shape. At the start, the riddle presented on the LCD is scrambled. When the button is pressed, the riddle is unscrambled and the data from the accelerometer is recorded. After a few seconds, the riddle scrambles and data is sent to the server. The server then responds with the type of motion and will solve the riddle if it is an O motion.
The LCD prompts the user to turn off the lights. To complete this task, users must cover the ESP32 for at least 2 seconds. The LCD displays task completed when it has detected low enough light levels.
At the end of the game, users are able to restart the game by pressing the right button. The end of the game will show a display screen saying game over and will reset if the right button is pressed.
I'm gonna hit ready to play.
I hit ready to play. Gotta skip through these prompts. Try taking 10 steps. Interesting. Oh yeah, I got 5 whole points.
Hello, my name is Melissa.
Hello, my name is Ethan.
Hello, my name is Alexa.
One thing I'm worried
A
about
comb?
is that the TA said that he wanted to play it himself.
Um,
But like, how would he play it if he doesn't have the ESP?
I think they do have it. It's almost the same setup as ours.
True.
A comb?
So I guess we have to add like the circuit diagram too, I guess.
Oh, that sounds like a
Your breath?